How to solve word problems involving coefficient linear expansion. Example number 1. The original length of the metal is 2 meters and the final length is 2.01 meter. The change in temperature is 60 Kelvin. Determine the coefficient of linear expansion. First, we determine the given. The given is initial length equals to 2 meter. Final length is equal to 2.01 meter. Change in length is equal to final length minus the initial length is equal to 2.01 meter minus 2 meter is equal to 0.01 meter. Change in temperature is equal to 50 Kelvin or 50 degrees Celsius. A stands for coefficient of linear expansion. Now we are going to find the unknown, which is the coefficient of linear expansion. Here's the solution. The formula is the change in length equals to coefficient of linear expansion times initial length times change in temperature. We are going to apply it to our given for our solution. 0.01 meter is equal to A times 2 meter times 50 degrees Celsius. 0.01 meter equals to 8 times 100 degrees Celsius. Now we are going to move the change in length and cancel meters both sides. It will become A equals to 0.01 times 100 degrees Celsius. A is equal to 0.0001 degrees Celsius raised to power of negative 1. To simplify it, the answer is the coefficient of linear expansion is equal to 10 times raised to the power of negative 4 degrees Celsius to the power of negative 1. Example number 2. Assume the architect's steel tape's measure is calibrated at 20 Celsius. A reading of 60 meter is found when the tape measure is used to determine the width of the building lot when the temperature is 30 Celsius. How great is the error does the temperature difference introduce? The coefficient of linear expansion of steel is 1.2 times 10 raised to the power of negative 5 degrees Celsius. Now we are going to identify the given. The given is since change in temperature is equal to 20 degrees Celsius minus to negative 30 degrees Celsius is equal to 50 degrees Celsius. Since both have negative sign, we're going to add it. 60 meter for the length of steel tapes shrink by. Given is coefficient of linear expansion is equals to 1.2 times raised to the power of negative 5 degrees Celsius. Initial length is 60 meters. The change in temperature is 50 degrees Celsius. We're going to find the unknown, which is the change of length. We are going to apply this given in our formula. Change in length equals to coefficient of linear expansion times initial length times change in temperature. Here's the solution. A is equal to 1.2 times 10 raised to the power of negative 5 degrees Celsius times 60 meter times 50 degrees Celsius is equal to 3,600 or 36 millimeter. The answer is great error is 36 millimeter. Next, solving word problem involving heat capacity. Example number 1. A 800 gram of cube of lead is heated from 30 degrees to 65 Celsius. How much energy was required to heat the lead? Specific heat of the lead is 0.306 joules per gram degree Celsius. Now we are going to identify the given is mass is equals to 800 grams. Specific heat is equals to 0.06 joules per gram degree Celsius. And the change in temperature is equal to final temperature minus initial temperatures equal to 65 degrees Celsius minus 30 degrees Celsius is equal to 35 degrees Celsius. Then we are going to apply the given to our formula. Q equals to mass times heat capacity times change in temperature. Our solution is Q is equal to 800 grams times 0.06 joules per gram degrees Celsius times 35 degrees Celsius. We are going to cancel the grams and Celsius both sides, so Q is equal to 8,568 joules. The final answer is it takes 8,568 joules of energy to heat the lead cube from 30 Celsius to 65 Celsius. Example number 2. The specific heat of gold is 129 joules per kilogram Kelvin. What is the quantity of heat energy required to raise temperature of 200 grams of gold by 75.0 Kelvin? The mass of gold is M equals 200 grams equals 0.200 kilograms. Then we are going to identify the given. The given is mass is equals to 0.200 kilograms. Specific heat is 129 joules per kilogram. Change in temperature is equals to 75.0 Kelvin. Then we are going to apply this given to our formula Q. Q is equals to mass times specific heat times changes in temperature. Our solution is Q is equals to 0.200 kilogram times 129 joules per kilogram Kelvin times 75.0 Kelvin. So Q is equals to 1935 joules. The final answer is the energy required to raise the temperature of a piece of gold is 1935 joules.